Okay, so we are continuing our mission to eat the whale of the final, one bite at a time. Previously, we've talked about functions, we've talked about sequences. Today, we have a new subject. The essential question is, so let me change my font size here. What types of numbers go in the domain? That's the input. And the topic and objective for today, in other words, the assignment that this covers, is called function domain word problems. All right. So in our notes, I just like to remind you what to draw a function picture. Remember, always draw a function diagram picture. Okay, so the way that I've taught you to do these, I'm going to draw mine actually out to the side here because I'm just about out of room. We're going to draw the middle part is the function, and into that is going to be an arrow going in and an arrow going out. So I've got something that goes into my function and something that comes out of my function. And I need to know what goes in and what comes out. That's the most important thing. So if I had f of x, then the variable x goes in and the variable f comes out. And every time I have a function word problem, whenever I am doing a function word problem, I always draw this picture because I need to know what the variables are to start with. So let's do a word problem. Mia is rolling a pair of six-sided dice. So the situation is roughly like this one. So Mia has a couple of six-sided dice, and she's rolling these dice over and over again. P of n models the probability of an event that the sum of the dice is n. So she rolls her two dice, and then she adds up the two numbers, and that's the inputs. The output is the likelihood that that happens. So it actually is the case that little middle numbers like 8 are more likely because you can add up to 8 many different ways. 6 plus 2, 3 plus 3 plus 5, 4 plus 4. There's a lot of ways to make 8s, but there's only one way to make 2. So the probability is a nonlinear function. Like that's a very rare occurrence. Okay, so I want the probability that the sum of the dice is n. So let's draw our function diagram. The oval is going to go in the middle. This is the first thing I look at when I look at the word problem. It says P of n. That tells me what my functional relationship is. I label it in the middle. That means that n goes in, n is the input, so let's see. F of x is function notation, so f of the input equals the output. Okay, so this was function notation. You can tell what's the input because the input is inside. Whatever's inside these is in the parenthesis is the input. This is in the parentheses, so n is the input, p is the output. The domain are these numbers up here. The domain are the input numbers. The range are the output numbers. Okay, so I've got the domain n going in and the range p that's coming out. So now let's label what the variables are. P of n labels the probability of the event that the sum of the dice is n. So n is the sum of the dice. Okay, so I probably can clean that up a little bit. Sum of dice is n, and the range is p. So Mia, who the Mia is this person, is taking dice, adding the two numbers together, and then asking what's the likelihood that they add up to 10, say. So they can add up to a whole bunch of different kinds of numbers. So let's see. Which number type is more appropriate for the domain of P? So I'm going to duplicate this over here. So this is the domain. And then output was the range. Okay, so when it says which number type is more appropriate for the domain, it's asking about the sum of the dice numbers. So we want to say, what kind of numbers are the sum of the dice? Are they integers? Integers are numbers like 1, 2, 3. In other words, these are not decimals. Real numbers are decimals. 1.358, 2.6, okay? So the sum of the dice. Is the sum of the dice more like 1, 2, 3, or is it more like decimals? The answer is that it's more like 1, 2, and 3 because the dice only have particular numbers. And now, what's the appropriate domains? Well, let's look. If I had both of the dice, as a 1, so if this was a 1 and this was a 1, then the sum would be 2. So the smallest sum that you could get out of dice would be 2, and the biggest sum that you could get, well, the most that they could get, if you added these together, would be 12, because that would be 6 plus 6. So the domain has to be more than 2, but less than 12. And the one that says that the sum of the dice is more than 2, but less than 12 is this one down here. So the correct answer is the sum of the dice is more than 2, but less than 12. Let's practice that again. So I've got my second problem over here. This one has more words, doesn't it? Mason stands on the 5th step of a vertical ladder. The ladder has 15 steps, so I have to draw a really complicated ladder here. So I'm going to draw the left side of the ladder and then the right side of the ladder. And he starts on the 5th step, and the ladder has 15 steps. So I need to draw a ladder that has 15 steps. 1, 2, 3, 4, 5. That's where Mason stands. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so there's the ladder that Mason is standing on. It has 15 steps. And now I'm going to make my function diagram. That's actually one of the steps here is to make a drawing. So now I need a function diagram. I want to know what goes in, what comes out, and I'm going to pay attention. Really important, always paying attention to what the function is, h of n. So I highlight that in my brain, or using a highlighter. H of n models the height above the ground in Mason's feet in meters after moving n steps. Okay, so n goes in, h comes out. N is the number of steps that he's on, so which step he's on. Another word for a step on a ladder is called a rung. So as he goes up the ladder, what happens? Well, he gets further off the ground. So this is the height. Okay, so let's figure out which one of these is the domain. This up here is the domain, because the domain is the input numbers. This down here is the range, because the range is the output numbers. It's about to ask us about the domain, so it's going to ask us about the input numbers. And what do we know about the input numbers? Well, we know that he stands on the 5th step, so 1, 2, 3, 4, 5. Okay, so here's Mason. He's on step number 5. And he climbs up to 15 steps, and then he's going to go up here. Okay, so he can be somewhere between 5 steps to 15 steps. So his step is somewhere between 5 and 15 steps. That's the step that he's on. And he doesn't go halfway. And if he stepped halfway, then he'd probably fall off the ladder. He can only go 5th step, 6th step, 7th step. If he did 7.1, he'd fall off the ladder. So these have to be integers. So let's see what we think about the answer here. Okay, what do we know about the domain, the input numbers? The domain are the steps. Okay, what do we know is more appropriate for the steps? We know that there are integers, like 1, 2, 3, not real numbers, because these would be decimals. 1.35, that's bad because he would fall off the ladder. All right, the other thing that we know is which rungs he was standing on. He was standing on 5 and he went up to 15, and that's a little bit confusing because I don't see between 5 and 15 here. So it must mean he's standing on the 5th step, but n after he moves 5 steps, or n steps above 5. So how many steps can he move? So he can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 steps before he runs out of room. And then it says if he goes down the letter n is negative. So this would be, it's saying that this is where 0 is. Up here, it can go up to positive 10. And then if he descends, those are negative steps. If he goes down the letter n is negative. So this must be the 0th step. That means he can go 10 steps up, or he can go 5 steps down. All right, so that means my domain is going to be this guy here. So he can either go 5 steps down the ladder or he can go 10 steps up the ladder, and that is going to be the